Hai, Assalamualaikum warahmatullahi wabarakatuh and very good day to our lecturer Dr. Safianu Bashir dan Juma and fellow classmates. We are Group 2 and today we will present our mini project on the application of engineering statics in real world problem for the course BDA 10203.
Okay, Assalamualaikum. My name is Muhammad Danish Saufi bin Nur Hassan, and I will be presenting and explain about the objective of the project and introduction. Okay, first of all, the main objective of this project is to apply the principle of engineering statics to solve the real world problems. First, we aim to analyze the force vectors and resultant force using a soccer ball as for example. And second, we study the rigid body equilibrium, that are particularly the moment of a couple through a tower crane application. And third, we analyze the centroid and the center of gravity, which are critical for structural stability. And throughout the project, we also emphasize the use of the free body diagrams and the equilibrium equations, which are essential tools for the mechanical engineers. Okay, for the next part is the introduction to engineering statics. And firstly, engineering statics is a branch of mechanics that deals with bodies in equilibrium, meaning that the body is either at rest or moving with a constant velocity. And in equilibrium, the sum of all forces and the sum of all the moments acting on a body that must be a zero. And this principle are extremely important in engineering because they ensure that structures such as a building, the bridge, the crane that can withstand the external loads without the failure. And this project connects the theoretical knowledge we learn in class with a practical engineering situation.
Application of engineering statics in real world problem for the course BDA 10203. Moving on to our focus study here, problem A, the soccer ball, which focus on force analysis. In this real scenario, we analyze a soccer ball being kicked at a specific angle. The force acting at the instant of impact include the applied kick before, the weight of the ball acting vertically downward. Our engineering objective here is to determine the resultant force acting on the ball using resolution of force and vector addition.
Assalamualaikum, my name is Muhammad Hazim Al-Asli and I will be presenting the methodology for problem A. To analyze the forces acting on the soccer ball effectively, we first had to establish a few engineering assumptions. First, we treated the ball as a single particle rather than a complex shape. We also decided to neglect air resistance to simplify the calculation, and we focused our analysis strictly on the instant of impact, with time equals 0. Our step-by-step process is, we began by constructing a free body diagram to visualize the interactions. We then resolved the applied kick force into its horizontal X and vertical Y components. We accounted for the weight of the ball acting on downward vertical force. Finally, we summed these forces into both directions to determine our final outputs, the magnitude and the direction of resultant force. Then we look at the results of the analysis. For this calculation, we use the following parameters: a kick force of 600 Newton applied at a 30-degree angle, and a standard soccer ball mass of 0.5 kilograms. After applying the equations of equilibrium, we found that the magnitude of the resultant force is 597.8 newtons. The direction of this force was calculated to be 29.6 degrees above the horizontal. From an engineering perspective, this gives us an interesting insight. You will notice the angle dropped slightly from the original 30 degrees, kicked down to 39.6 degrees. This confirms that while gravity does reduce the vertical components of force slightly, the overall resultant direction remains very close to the original angle of the kick.
Assalamualaikum. My name is Nurul Nazira binti Muhammad Syukur. Matric number CD 250185. Today I will explain about tower crane, which is from topic rigid body. For the real world application for this topic, I have chosen a topic about tower crane lifting a heavy load. Main engineering concern is crane stability and prevention of tipping. Forces acting on the crane are load weight, counterweight, self-weight of jig, and reaction forces at the mast. Key statics concept for this topic is moment of a couple and rotational equilibrium. Okay, for the methodology for this problem, crane are modeled as a rigid body. Free body diagram constructed by isolating the jig. Identified parameters for this problem are load distance from mass, counterweight distance from mass, and center of gravity of the jig. Applied equilibrium condition are summation of moments equals to 0. Clockwise moments balanced by anti-clockwise moments. Okay, for the results for this problem, given tension in tie member BC equals to 400 Newton. Vector analysis used to determine force components. Moment generated by load and counterweight are calculated. Net couple moment transferred to crane mass. Engineering significance determine required mass strength and ensure safe crane operation under load.
Hi, Assalamualaikum. My name is Muhammad Nazmi Rizwani Bezainan. My metric number is CD250010. So today I will briefly cover about topic centroid and center of gravity. So my study case for this topic is a tower crane that consists of two components, the vertical tower for stability and the horizontal jib for lifting material. So we have two key definitions that we need to understand about centroid and center of gravity. Centroid is a geometric center and center of gravity is the point where the total weight acts. So stability condition for safe operation, the center of gravity must lie within the crane base footprint to prevent tipping, or in Malay, jatuh. So the conclusion here is understand this aspect is crucial for safe crane operation. So let have a look to our case study. So we have analyzed the stability of a tower crane using some assumed parameter. So this is our following specification. The tower height is 30 meter. The tower mass is 15,000 kilo. The jib length is 20 meter and the jib mass is 5,000 kilo. From our calculation, the position of the center of gravity is coordinate at 2.5 meter and 18.75 meter. Assume uniform density, the centroid coincides with the center of gravity, which simplify our analysis, right? The alignment of the center of gravity within the base footprint ensure the crane stability during operation, preventing tipping hazard. So in a conclusion, our analysis demonstrates that with the given parameter, the tower crane remains stable.
To conclude our presentation, this project has successfully applied static theory to solve real-world problems. First, we use force analysis to predict the motion behavior of the soccer ball. And two, we apply moment equilibrium to ensure the stability of the tower crane. Three, we perform a center of gravity analysis to prevent tipping. This project reaffirms the importance of free body diagram and equilibrium equation, demonstrating the static is essential for engineering safety and design. That brings us to the end of our presentation. Thank you for listening.